So good afternoon. Greg Keller here with our systems, technical principal and co-founder. And we are a small cycle provider for lots of researchers. At the end of the day, we have lots of interesting toys and technologies and tools for researchers that we make available remotely or on site to those researchers. So we've been using MVX for some of our more aggressive researchers with very strong data challenges, and we'll talk a little bit more about what we've seen as we go here. So I'm trying to advance the slide. There we are. So founded in 2005, we actually are a spin-out of the National Center for Supercomputing Applications, where we worked on, world-class systems and world-class research challenges. Our focus is on primarily commercial and some academic researchers and putting tools in their hands that they wouldn't otherwise be able to get a hold of. Our mission is to provide services that benefit both commercial and academic communities by improving the availability of those tools, and managing the life cycle is really the important thing. So taking technologies that have bleeding edge users in the first year and then over the years would be retired, we can keep those online for other researchers and make the best of those technologies for everyone involved, get the best use out of that. So we have key customers in several different areas. A couple noted here are financial and actuarial, some oil and gas, some manufacturing. But essentially, our systems are used to do all kinds of different research, and month to month, year to year, we don't necessarily know in advance exactly what the use case or application set is going to be for a given system or technology. So we need to find things that give us lots of strong performance capabilities without having a fixed structure, without having something that's just locked in and it's only going to be really good at this type of application or this type of code. So key partners that we work with, obviously RNA. We have other partners at InfoScale that make some amazing software for flexibly managing our environment through RAM-based root file systems and other neat technologies so that we can quickly convert from one use case to another. Nimbus is an application portal that's helping us redefine the challenge of licensing software in these cloudy days and special environments where you may not need a license for a whole year. You might just need it for a week or a month. So they're putting together the portals and the relationships there. And then Wolfram Research, obviously a pioneer. Wolfram Alpha is a big project that we helped on to help make data and information quickly available to people in terms and ways that they can understand. So different applications, again, we run the gamut of different types of researchers doing different types of computation, some of which are memory bandwidth bound, some of which are CPU bound, and some of which are disk bound. And so we're always looking for things that will help us get across that growing gap between how many flops are available on a system and how quickly I can access memory and storage. RNA has a great product from our perspective in that we can meet a lot of those edge case uses and get a lot more bang for our buck out of the CPU horsepower because we can keep it fed with the data that it needs in order to continue forward. So solution sets in the financial services, genomics, computer-aided engineering, all kinds of different folks doing different things over time with the same infrastructure here. So common workload challenges. Well, we're routinely dealing with data-intensive applications. And the longer that a system waits to load that data off of a storage system, the more time that is effectively lost or wasted. And it is routine for us to see with our customers that the storage load time can easily be 60 or 80% of the total time it takes to complete a particular job set. And so for us, finding ways to ease that and finding ways to get that data fed into the CPUs faster is a win-win for everyone. in many cases, we're operating on very large common data sets, and we're dealing with very complex file systems on the back end in order to be able to parallelize and do different things to get those data sets, kind of the hot data, available immediately. There are all kinds of painful things that researchers have done to try and work around these, central file system bottlenecks. To name just a few are copying databases to each and every compute node and trying to keep them synchronized. There's a certain type of message passing that I've seen many researchers still relying on, where they're actually writing files and watching for those files to come into existence because they're not MPI aware. All kinds of different things that make traditional file systems crazy, and things that RNA's MVX product can make much, much faster for those researchers. So they don't have to revisit the code or rewrite it. They can simply add in a software layer, reutilize the exact same hardware more efficiently. So at our systems, we've got MVX deployed in a couple of different interesting ways. In the memory cloud scenario, we have taken essentially a large set of servers. And when we build out our servers, like most facilities, I would guess, oftentimes we put in enough RAM to get the total memory bandwidth available in the system, and we don't always need all of that capacity for all of our applications. So this is a perfect use case for us, where we can take that extra capacity that's available in systems and underutilized, put it into the memory cloud via MVX, and make it available for those applications that do occasionally or routinely need to burst out beyond the RAM that's trapped inside of that one server. This allows us to get away from buying exotically priced DIMMs and exotically priced systems, so that we can cram enough DIMMs in them to be able to handle those edge case applications, and just reuse the same infrastructure that we already have in place to do much, much larger science, and to dramatically increase the predictability of the performance. So one of the things that we've seen along the way is, if we try and put too much RAM in one place and centralize that RAM into one system, it becomes very difficult for us to get to that from other places. And so when we distribute the RAM across multiple systems, we have what I call distributed aggregation. And so we can now allow many systems to access that memory cloud and get the capability of all those systems, including all the network cards and switches, instead of bottlenecking everything back down to a single system or a small set of systems with a relatively small set of inbound and outbound network ports. There we go. So how MVX benefits our systems? Well, as with many application workloads, there's generally terabytes of data that need to be there, and a certain subset of that will be hot or in use active at a given point in time. So what MVX allows us to do is have all that active data accessed from cache that's stored out in the compute cluster in that extra RAM, rather than all of them bottlenecking on a small set of ports to get to a relatively small set of spindles. This, again, dramatic reduction in the execution time, because at the moment that a given process needs to access data, if it's been accessed recently by anything else, it's already in RAM and available, at RDMA speeds, rather than having to wait for spindles to spin up. For some of our application loads, we've seen a 400% increase in overall capacity, and that really understates the value, because above and beyond that 400% increase in the ability to get work done, we also see a large improvement in the stability of how much work we get done over time. So things that used to spike because sometimes it would fit within the cache of the storage subsystem and sometimes it wouldn't, now we have a much, much more consistent, full-speed run for those same applications. And again, I mentioned the distributed aggregation. Having that memory resource available but distributed across lots of systems means that even when I'm hitting it under full load, I'm not really stealing that much time or putting that much load on any one of those servers that are donating memory cache into the pool. So definitely an order of magnitude reduction in disk I/O. We actually looked at what it would take to deploy a disk system to reach something like the type of performance that we can get through MVX, and it's just staggering how quickly the expenses spin up when you're trying to get to tens or hundreds of gigabytes per second of throughput. With MVX, on hardware we already own, we're able to get that same throughput, that same performance to the data that matters at that moment in time without putting in those massively expensive disk subsystems. Also, we don't have to go through the gyrations of trying to replicate data or keep multiple copies in multiple places and hope that they stay synchronized well enough for the applications to complete and have a coherent result. We easily save 10 times what it would have cost us to do a disk deployment or other strategies to get enough cache in front of these applications that they didn't bottleneck on spindles. And so, in summary, what we see with MVX is the opportunity to get much, much greater performance for client applications, increase the amount of work they can get done with the systems that we've provided, and accelerate their research. And that our systems is all about finding ways to make researchers move faster, get through their hypotheses faster so that we can get real-world solutions to real-world problems. In my environment, I have a dramatic reduction in new spend on storage, and that's helpful, A, because it's a very cost-competitive market, but also because I don't have to go buy a bunch of new hardware for a relatively short-term, weeks or months project in order to get the performance I need. I can spin up the software layers that I need when I need them without any additional capital spend. And that gives me a lot of flexibility for servicing my future demands. I don't know today what I'll need in 6 or 9 months. If I've already purchased hardware, then I have the challenge of trying to see every, when you're a hammer, everything looks like a nail, and when you have a wall of storage spindles, everything starts to look like, it needs a parallel file system. What RNA MVX gives me is the ability to look at each problem and really design a caching layer that fits that application's needs specifically without having to jump straight to a huge hardware investment. So that, I think, is the presentation, and I'll turn the mic back over.